We're facing a real data dilemma. We're creating a lot more than we can store. What we do save is degrading with each passing generation. And the networking technology that we rely on uses way too much power. This is driving us at Microsoft to radically rethink and invent new, disruptive technologies. The media industry tell us that the films, music, the content that they produce is the value of their companies. And they go to extreme lengths to try to maintain it. And we hear that from other industries too. Like the banking sector, they understand exactly how risky current storage can be. All of that is just a mishap away from being lost. At Microsoft, we've been working hard at optimizing our cloud-scale storage using existing technologies. This new media is a platter of silica. Basically, it's a bit of glass. But if you look at it very carefully, you can see data that is stored inside it. A piece of glass like this, theoretically, can store hundreds of terabytes of data. This new media writes data into glass using pulsed femtosecond lasers. These are lasers that are firing extremely short pulses of light into the piece of glass. And where that laser hit in the glass, a small dot was created. And that dot can store data. It turns out that glass is remarkably resilient. Once you store your data in this, the data is going to be there for 100, 1,000, even 10,000 years. Data storage is one of the challenges we're thinking about. The other one is sustainable networking. It's about the energy and the speed with which we can transfer data over the network to access that storage. If you think of a traditional data center at the moment, when you send some data, it goes from a server in a rack to a top-of-rack switch. That top-of-rack switch converts the data from electrons to photons and sends it to another switch, where it's converted back so that this can then decide where to send it next. And this process is then repeated millions of times across the data center. That means we're wasting huge amounts of energy. So what we're hoping to do is to allow you to convert it just once, and then whoosh, we're going to send it across the entire network as light. We went all in to create an optical chip that could switch between the different light colors at the nanosecond range. So the great thing about this new optical networking is that the core is completely passive. All that happens is that it steers beams of light. It requires no additional energy to do that. We're trying to also incorporate it with optical storage to create new types of data centers that we can deploy in the most arid or icebound regions, out at sea, or even underwater. We're seeing a future where we can bring all of these technologies together. We're not there yet, but every day we're making progress on that dream.